Hey, thank you so much for having me. I'm a product manager at AWS. I work on the non-relational database services. Just want to make sure you can hear me back in the corner. Perfectly good and loud? All right. So what we're going to talk about today is databases on AWS, how we think about databases, and then choosing the right tool for the job. We're going to do a bunch of demos, and we're going to run some code. I just want to set the context really quick and kind of talk about how we got here today. I think we can all attest when we take out our cell phones and you look at the applications that you use, ride hailings, social media, dating, that the requirements for these applications are significantly different than they used to be for the application that ran on a server underneath somebody's desk, right? Millions of users. If you think about, on Snapchat, when the Cubs won the World Series, you might have tens of millions of customers coming to your platform or coming to your application at one particular moment. And when we think about applications or architecting for that, it's a completely different dynamic. Large data, globally located. If you have a ride-hailing app and you get off the plane in London, you expect it to work in London. You don't expect to have latency go across half the planet and have really slow refreshes. So microsecond latency, web, mobile, IoT, it needs to work everywhere. And where that leaves us is a one-size-fits-all database. It just doesn't work anymore. And what we're seeing our customers do is actually doing what actually engineers and developers do best is taking large, complex problems, if you can think about what would it look like for an Airbnb application, and breaking it down into individual use cases, and then working backwards from the use cases, and then pairing it with, hey, what is the right tool for the job, or what is the right database for the job, given this particular use case? And we see these 5, 6 predominant data models used across customers. You have relational and key value and document, in memory, graph, and search. So what I want to do with our time today is I want to go through a demo application with you, break apart this demo application. We're going to do 4 distinct use cases. We're going to do product catalog and shopping cart. We're going to do a product search. We're going to look at a leaderboard, and we're going to look at a recommendation engine. All right, so to do this, we built a web application for this demo, and it's a bookstore. I think everybody kind of has familiarity with the concept or has used it once before. But if you look at this application, there's multiple different use cases here, right? We have our product catalog, we have our shopping cart, we have search. So let's get into the first use case. Well, with our product table, we think about these individual items. Hey, what describes a book? So let me go into this particular table, and let me pick out a good one. We'll take spaghetti. And let's look at this data. Typically, in a product catalog, you have a unique identifier, which is a GUID, and then you have a bunch of other attributes which describe that particular book. Hey, what is the S3 bucket that the particular image resides in? How much does it cost? What's the rating? What's the title of the book? Who's the author? So let's do this. We'll call this, we'll title our book Spaghetti Vegas. We'll add a new unique identifier to it, and we'll add a new product to our product table. And why I'm using DynamoDB or a key value store for this particular use case is I only have 58, 59, 60 products at this time. But this use case of just accessing just a key within a range of values lends itself really well to a scale-out architecture. So I can have millions of products, or I can have tens of millions of products, and the performance of a key value gets and puts scales linearly with the size of data. And that's a really good fit for a use case of a product table or a shopping cart. So let me save this data. And let's go back to our website. We'll refresh. And then if we go to cookbooks, somewhere down here we should see Spaghetti Las Vegas. There it is right there. Right? So that's the new book we added. But as the developer for this website, I know this is not how my customers are going to search for products, right? You've heard about the spaghetti book about Las Vegas. You're not going to go look through a whole list. You're going to go up to the search bar, and you're going to type in Vegas, and then something that's maybe spelled right, maybe not spelled right. And you're going to search for a book that way, right? And that's a very natural experience. I think we've all become accustomed to a really great search experience. But you should be asking yourself the question at this point. I just added a book into DynamoDB, but I just went and I queried a search index. So how did I keep those two databases in sync with each other? And how do we do that as a developer and make that really easy so I don't have to write complicated code? Well, there's a really great feature in DynamoDB. We'll create a demo table. Called streams. And I'm going to create a table. And what streams does is every time we add an item, modify an item, or delete an item, it'll actually write it to a queue. And then we can use this queue to process data asynchronously. And in this case, we wrote it to Amazon Elasticsearch Service. So we can keep our product table in sync with our search index. So I'll enable that streams. And then we're going to go to add our trigger. And I've already written a Lambda function ahead of time. We're just saying how the turkey is cooked. And I'll pick a Lambda function, and I'll say a batch size of 1, because I want to keep my product table in sync with my search index. And I'm off to the races. So now every time that I update my product table, I can keep my search index up to date. So that's the second experience. We have a great search. Now, once I kind of get the basics for my website up and running, the next use case I want to provide for my customers is a bestsellers list, right? This is a highly curated list of the books that everybody on my website has bought, and I want to make sure that that this is a really performant experience for people that come to my site. What I don't want to be doing here is choosing a data store behind the scenes that's going to compromise functionality or performance for this particular use case. If you can imagine, I'm expected to sell a lot of books, millions of books. And if I have to do a table scan across an entire database for every customer that comes to this particular this leaderboard, that's going to be really expensive, and it's not going to the performance won't scale linearly with the data size. So for this particular experience, I've chosen Amazon Elasticache for Redis. And the reason why is Redis has a really nice feature called a sorted set. And sorted sets make building leaderboards like this very easy. So let me go show you just what the data model looks like for Elasticache. Now, I already have console access to my Redis node. And the query I'm going to run is just querying that sorted set, that specialized data function, that will show me the items that are in my leaderboard. So we had 3 products that were there, and they're ranked descending. So the top item had 21 purchases, and the last one had 15. So if we buy the last one, we add 6 more items in our application, we're going to pump that up to the top of the leaderboard. So we'll go down to ice cream, and we'll add 6 items, we'll check out, and we'll pay. Just like we did with Elasticsearch, we also set up a stream on our orders table. So every time we write to our orders table, we're going to write that to our sorted set in Elasticache for Redis. And if we go back here and we update this, right, we can see now that the top item is 21 purchases, and we've made a really simple, instead of having to query an entire range of purchases, we have a really simple data structure here that makes it very easy to build really performant leaderboards. So if we go back to our bestsellers list, right, ice cream goes up to the top of the list, and we have a really nice search experience. We don't have to pull back a bunch of records or do complicated queries. It's just a very simple get and put operation. All right. For our fourth and final use case, we want to look at a social graph. Now, I think, for the customers, when we thought about developing this, we know that there's a lot of social context built around, the different experiences that we have. And if we know our friends have bought in a particular book, that has a lot of weight to us, right? That's a recommendation, or that's validation that these people, they found value in this particular book, and as building the site, we want to provide that to our customers. Now, let me show you, when I think about graph databases, for me, I'm a very visual learner, so I always like to kind of visualize what I'm looking at with a graph, and I think it actually makes writing queries a lot easier. So this is actually the graph for the data set that we use for this website. And if you're not familiar with graphs, the blue circles, they're called vertexes, and they're basically nouns. So in this case, the dark blue are people, and then the light blue circles are books. and the orange circles are categories. So you can see the relationships between this person purchased this book, which was also purchased by this person, and the graph kind of goes on. So if we go back to our website, what we're looking at in this particular scenario is, hey, who are my friends that have purchased this book? But if I want to add another experience to my website, and I think one that most folks are familiar with, let's say we go to the books page, and that's the next experience I want to build, and we want to write that query of, hey, tell me all the people that have purchased this book, and what are the other items that they have purchased, right? So it's kind of like, okay, well, if they bought, I don't know, Spaghetti Las Vegas, what are the other books that people have purchased that have bought in this book? And if we go look at this in a graph database, this is an example of how you would write that query. So I'll just kind of walk through this syntax with you. Is the G stands for a graph, and we're going to say book 34. And if you kind of visualize, the vertexes and the edges, what we first want to do in this query is say, hey, given this book, we want to go out of vertex and say, okay, well, who has purchased that, right? So we have a bunch of connections of people that have purchased this book. And then for each of those people, what other books have they purchased? And then we want to filter out our book, and then we want to order by descending rating. And it becomes a very simplified query. Now, using a graph database for this use case, this is what its purpose is. This is what it's meant to do, and it's very simplified. I think this is a great example of where you can get in trouble by choosing a database that wasn't built to do graphs and say, like, writing recursive functions to be able to do this in a different language or a different type of database, where it becomes very burdensome, and then you spend most of your time trying to figure out how to validate queries that otherwise are just kind of built into the system for a purpose-built database. So let's go run this. And I've already logged into my Neptune console, which is Gremlin. And we can run this query, and we just get a very simple result set back that tells us, hey, these are the other books, and then we can use that to go back to our orders table and populate our web experience. So it's a really simple example of the power of a graph database query. All right. So all right, so in a quick recap, what we did is we used a demo application, and we looked at a bunch of different use cases, right? We looked at our product catalog, which was, we used a key value store because a key value store, lended really well to having a unique ID and attributes. We used a graph database to be able to do a social recommendation engine. We used an in-memory data store with Redis to be able to do a leaderboard. And we used search to be able to power full-text search for our product search. So we took one application that looks very put together on the surface. We broke it down into individual pieces, and then took that use case and matched it with the particular database. But wait, there's more. So the whole application that you just saw, we made available today on GitHub, open source, all the pictures, everything is available to you. AWS samples, it's under the AWS bookstore demo app repo. And we also provided a CloudFormation template, so if you want to spin up this application in your own account, it's just a one-click experience, which is really nice, and then you can kind of start querying the different databases and see how it's architected. And it's a good starting point to kind of play with these different use cases. So with that, I thank you for your time. And the next time you think about building applications, really think about taking a step back and saying, what is the use case, and then what is the best database to use that use case. And I think you'll have a much better experience where you don't have to compromise on functionality, performance, or scale down the road. So appreciate the time. Thank you very much.